Hey, welcome everybody to 9.5, Addition, Subtraction, and Complex Fractions. So today, instead of just simplifying fractions, we're going to actually be adding and subtracting. So, to start off with, we're going to review how to add and subtract fractions. I'm hoping that most of you remember this, but for those of you who don't, when I'm adding or subtracting fractions, I have to have a common denominator. So if I look at number 1, I've got 1/2 plus 3/4. Before I can add fractions, I need the bottom number to be the same. What you want to do then is look for a number that is a common multiple of 2 and 4. And when I say multiple, I mean 2 times 1, 2 times 2, 2 times 3, so on. And you could use any multiple, but it's the fastest if you use the least common multiple. So in this situation, 4 would be the least common multiple. I want to make the bottom of this first fraction a 4 then, so I want to multiply it by 2. I can't just multiply the bottom by 2, I have to also multiply the top, so I multiply the fraction by 2 over 2. So that's actually the same thing as 2/4. Once I have the same bottom, add the top, bottom stays the same. And now once you have the same bottom, it's as if I have 2/4 plus 3/4. How many fourths total do I have is what you want to ask yourself. Now remember, there's a lot of common denominators you can have. So let's look at number 2. And when I look at this, the least common multiple or least common denominator would be 12. Some of you, though, may have been thinking 4 times 6 to get 24. And now either one's okay, but if you use the lowest one, it will be less reducing later. So that's what I'm going to use. 4 and 6 both divide into 12. Check this out. To get 12 here, I need to multiply by 2. To get 12 here, I need to multiply by 3. So the first fraction ends up being 9/12, and the second fraction ends up being 10/12. So my final answer is -1/12. Alright, I want you to pause the video and try number 3. Alright, I got 47/56, and 56 ends up being the least common multiple as well. Alright, so I hope at this point you're kind of like, oh yeah, that's easy, I remember how to do that. It gets a little harder to find that common denominator when we have variables, so that's the next thing I want to talk about. Starting out easy, and when I say least common multiple, that would be the bottom number I'm looking for. A multiple are things that multiply. I multiply by my number to get them. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So these are all multiples of 3. Here's the multiples of 7, 7, 14, 21, and so on. I want to stop though. When I find the least common multiple, I want the smallest number that matches in both lists. And it ends up being 21 in this situation. Alright, so here's what you do when you have variables. In this situation, x and 5 have nothing overlapping. First you want to ask yourself, is there anything that's overlapping? In this situation, there's not, so 5 and x are both in there for the least common multiple. You know what, let me just do a few and then I'll come back and clarify. Let's look at D next. Alright, here 2 and 3 are just different numbers. The least common multiple of 2 and 3 would be 6. I knew that in my head, but if you needed to, you could write out the multiples. Now, when I look at x squared and x cubed, here's where it gets tricky. So the least common multiple is the smallest thing I could put so that both lists, everything's satisfied. Now this one has an x squared and this one has an x cubed. I can't put x squared because that would be smaller than x cubed, and x cubed is the biggest one, so that's what I put down. Here's kind of like the shortcut I usually tell my students. You want to use every factor you see. You don't have to repeat unless it happens twice, and if you have variables with exponents, you're looking for the larger exponent for the least common multiple. Let me say more. Let's look at C. So in this situation, you might be thinking, oh, they both have an x. Doesn't work that way if this is locked in there with a parenthesis. So in this situation, x counts as one factor and x plus 2 counts as the other factor. So my least common multiple would be me just multiplying the two numbers together. Looking at E and F, I can't really figure out what the factors of this are because it's a trinomial. So what I'm going to do is I'm going to factor it first, and then I'll find my least common multiple. All right, I want two things that multiply to be -6 but add to be -1. So think, what two things multiply to be -6 but add to be -1? All right, I'm thinking -3 and 2. All right, here's how this works for finding the least common multiple. Now, both of them have a x minus 3, so that's going to be part of it. This one also has a x plus 2, so I'll put that down. So I don't have to put the x minus 3 down twice because it only appears once in each list, but I have to make sure everything's included that appears. So let me just go back and say more then. When I go back and look at B, I had to use everything that appears in my lists, 5x, didn't have to repeat. I use every factor that appears. I use every factor that appears, and x cubed is the bigger one, so that's the one I had to use. All right, let's look at F. And I want to be honest with you, this is going to become more clear as we go along. I realize that I'm not giving you very specific rules here. I'm just saying some stuff. There aren't really specific things I can tell you that work in every situation, because every situation is going to look a little bit different. That's why I'm not being extremely clear right now. So you'll get the hang of it as we do more examples. Now, in general, though, I'm looking to find what the factors are, and I don't know, again, what the factors are of this trinomial. So first I'm thinking that I'm going to factor out a 2. So I divide each piece by 2, and then I put my leftovers in a parentheses. I've got x squared plus 8x plus 16 in the parentheses. And now let's continue factoring this. So I'm looking for two things that multiply to be 16 but add to be 4. So I'm thinking x plus 4, x plus 4. All right, now here's what you got to think about. What unique things do I have? I've got a 2. It's in both lists though, so I only need to put it down once. I've got an x cubed. I've got an x plus 4 and an x plus 4. Because one of the lists has it twice, that's why I would put it down twice. All right, let's keep going, and I'll show you how we can apply this to some problems. Now, example 2 actually starts out easier than what we just did, so we'll go through these two quickly. When I look at example 2, they already have a common denominator, so if two things already have a common denominator, you can just add it like a normal fraction. Even though the x's there, doesn't matter, just normal fraction. So bottom stays the same, then I add the top. 4 plus 2 is 6. Now the only thing that's a little bit different here is that we do want to simplify it. Of course the x just stays there, but 6 divided by 3 is 2. Alright, let's look at B. So again, the bottom stays the same if you have the same bottom, and then work with the top. And in this situation, because I have a subtract sign, 2x minus 4. Now I can't add those together, so I just write them both down. Think back to what we did in section 9.4. Is there anything on top and bottom I can cancel? No, so that's my final answer. Alright, starting with example 3 is where we're going to use the least common multiple thing we were just talking about. So the thing is, I can't add or subtract these fractions until I have a common denominator. So I need to find the least common multiple to find a common denominator, and here's what we're going to do. First, factor it. And I mean the denominator, so factor the denominator. When I look at my two fractions I'm given for part A, on the left, 6x squared can't be factored. So I'm just going to look at the right. Think to yourself, what's the common number I could divide out of there? What's the common variable I could divide out? When you're dividing, you want the smallest one. I write down my leftovers. 4x squared divided by 4x is x. Negative 12x divided by 4x is negative 6. All right. And now I need to determine what I need to put on both sides. And now I just want to make a quick side note to help you understand what we're about to do. Let's suppose I have this problem right here. If I looked at the, let's make this a 4 just so you don't get confused. Okay, if I look at these denominators, this one has a 3 and this one has a 5. So this one is missing a 3, so I'll add a 3 to the top and bottom. the left one is missing a 5, so I'm not adding, I mean I'm multiplying a 5 on top and bottom. So our method is we're going to multiply by what it is missing. So look at this here. This one on the left, it's missing a x minus 6, so I put a x minus 6 over x minus 6. And it's also missing a 4. Now there is a least common multiple of 4 and 6 we could do, like I said before. So if I multiply by 4 over 4, it would be 24 on bottom, and if I multiplied by 3 or 2 instead, I could make them 12. But let's just, for this sake, make it 4, because usually that's what's going to happen, is that you can just use the other number you see. Anyways, so this one was missing a x minus 6, it was missing a 4. Does it have an x? It does. It actually has x squared, so we're covered with the x's. Alright, now let's look at the right fraction. What does this have here that this one is missing? Okay, the one on the left has x squared and this one only has an x, so I need another x to make them match up. This one has a 6 and this one does not. It's a 6 multiplied by it, not something locked inside there, so I need to also multiply by 6. And now, you know you are done if both of these bottom parts have the same chunks. So notice, a 4, a x minus 6, a 6, a x squared. Check. This has a 4, a x, x minus 6, x, and 6. Okay, but x times x is x squared, so we're covered there. So I hope you see what I'm saying. The bottoms have to have the same, all the same things all multiplied together. Here's what happens next. The bottom now, let's actually do 4 times 6, so that's 24. So I have 24 x squared times x minus 6. Now we're going to multiply this top out. And notice, you want to do things the simplest way possible. In this situation, if I multiply 4 times 5 first, that will be the simplest way here. So think, in my mind, I'm thinking, okay, 4 times 5 is 20, so I'm thinking 20 times x minus 6. So I'm going to distribute the 20, and I have 20x minus 120. And then for the right fraction, it has the same bottom as this one, because we made it so it has the same bottom as that one, remember? So it's going to be 24x squared times x minus 6. And then on top, this one's a little simpler, it just has 6x squared on top. Alright, last but not least, now it's a problem like what we did in example 2. So the bottoms are the same, so the bottom just stays 24x squared x minus 6. But I add the tops, so I'm going to add them because there's a plus sign. I would just combine like terms if I could. None of these are like terms, so if there's no like terms, that means I just have to write it all out. 6x squared I apologize, suddenly Windows Journal is not letting me write. 6x squared plus 20x minus 120 is what you should have on top. But because Windows Journal is suddenly not letting me write, I'm going to just stop this video here and catch up with me again with part 2.